Good morning, good afternoon, or good evening, depending upon where you live around the world. Do you have the saying in your part of the world about the dog with the bone? You probably do. And that's where I just won't leave it alone. And so too with the hub. I'm wanting to have an elegant, strong, flexible, you add the word, that'll be me, to this project. I take it perhaps way too far, and as I've been adding to the conversation, I have to remind myself this is, after all, just a bit of landscape architecture, which that to me means it's not a fine piece of furniture or engineering. It's a couple of bits of wood banged together to end up in a pleasing structure for the outside environment. In a previous life, I was a wedding photographer, and people would say, "Oh, that's a nice snap," and I'd just about go insane because you don't know what it means, And anyway, about the setup and the exposure and all these things that, from my perspective, there was a lot of work behind what went into something which for most people was a nice snap. So the engineer in me is still, and the builder in me is still saying, make life easy, but make it strong and safe. So, what is the easiest thing to do when we come to this? Drill a hole before we even dock it with an angle. Drill a hole 90 degrees to the end of the timber in the central axis, sufficiently deep enough to give strength to within the hole, and protection from the elements. You don't want anything too close to the surface because of the protective nature of the deeper positioning of the steel or the component below the surface means that it's more protected from weather, and it's not likely to cause an interference with or an issue with the moisture being retained near the surface of the timber. Anyway, that's technical, not for what we want to do here. So, before we dock the angles, pre-drill a hole, and we can then cut it to that prescribed angle. And for this one, for proxy, it's saying 15 degrees, which is, I think, one of the larger angles within my dome design. We can thread a rod in parallel to the long axis of the timber, and we can thread in my much preferred Spax style screw because of its thread design. There's other companies that make similar design, but I'm just using Spax because that's what's available in my country. So we still have to do something about this interface between the screw or bolt head and the hub. So we can choose, just excuse my zooming out awkwardly, I'll have to get a 3D mouse. Yes, big or we can cut these wedges or angle a nut, whatever, as I mentioned in the previous video. I think perhaps we can just set up a wee jig and cut or grind the required angle on it, which is, at this stage, it's flipping backwards and forwards between which one would be better. I've got a feeling this one would be, because it gives two nice surfaces to give pressure against the inner side of the hub. But either or. Why have I combined two different attachment methods? This one is perhaps you could say, the heavy duty version, and therefore that which gives the greatest strength to the hub. This, while giving a lot of strength to the hub, is more to do with the long-term use or longevity of the hub and struts, because we don't want any rotation. The deeper we go in section size for our struts, the more that's required to restrain any sideways or rotational movement. And then I had an idea, well, if you do it in this manner, this one is just square to the hub, eliminating the need for any of the little plates. So, and being the one that has the greatest impact on the strength of the hub, and it crossing the fibers of the timber, this orientation for the insert, in theory, would have greater strength and stability for the interface between the threads and the timber itself. Less likely to split because it's going into deeper and deeper sections of timber, so you're not close to the surface all the way along, and in parallel with the grain, so that any stresses in this, after all, it is the one that's doing most of the work. You don't really want this trying to split the timber, and this one holds it in place where we still have to have some sort of compensation or adapter plate here. So we've combined the two, and you've got the dovetailing effect, which means that it has a greater resistance to pull out. I think if we'd ever got to the stage where the dovetailing effect was what was stopping it from pulling out, something else has failed. But easy to install, and the beauty of this is that it can be installed after the hub and the rod have been installed, and you can install this from the outside. A lot of if you started to combine methods, you will have to have the rod, you can't thread it in, it has to be in place in the strut, and the hub slid over the hole and tightened up with a nut. This the top one you can install after the hub has started to be assembled. I've even seen where they've had hubs that have slots in them, and they slot the hub over the nut or the bolt, tighten it up, and then they can put the screw in the top. I think that's actually a really, really good combination, because as we become more and more to the point of completion for the structure of the dome, it becomes more and more rigid. Also a reason for not doing the nuts up tight to begin with. You just leave them with 2 or 3 millimeters or so slack, and then once everything's assembled, you can start nibbing up all the nuts to draw everything together. That's the case in a lot of engineering things. You don't want to have any one bolt that has been torqued up to a high level starting to have loads imparted on them while the other components are being assembled. So you need to have a little bit of wriggle room, and then once everything's in place, yes, then tighten everything up. Just an idea that when you're doing building up furniture, we always hear the complaint about IKEA furniture. How the hell does it go together? Well, one of the things is don't tighten everything up too soon. Okay, so that's it. This is my dog with a bone idea or story with the hubs. I think one of these two methods could be what we'll go with. This one has got an advantage over this, that it doesn't need the wee plate on the inside to compensate for the angle, but we'll see which one will win out. I should have a interface with you guys, people, and you could vote, or just tell me to move ahead. Okay, I'm waffling yet again. I'll see you later in the next one. Bye.